ladies and gentlemen, shh, guys, come on, let's go. So what Chapter 8 is going to be dealing with is we're looking at a topic of differential equations. And those of you that do take math and engineering classes, there's a whole course in college just on studying differential equations. So we're just touching on the tip of the iceberg when it comes to differential equations. First of all, when we talk about a differential equation, it is an equation involving one or more derivatives of an unknown function. So you're looking at an actual equation that has a derivative in the actual equations. The order of a differential equation is the order of the highest derivative. So when we talk about the order of a differential equation, it's based upon what the highest derivative is in the equation. So when you look at polynomial functions and polynomial equations, we talk about the degree of the polynomial, and the degree of the polynomial is determined by the highest exponent for the variable. The order of a differential equation will be determined upon the highest derivative in that particular equation. So for example, to determine the order of this particular differential equation, what derivative is given as this equation? This is a first, second, third. What derivative is given? First. So then we would call this a first order differential equation. When you look at the second equation, what's the highest derivative given in here? Second. So we would call this the second order differential equation. When you look at C, the highest derivative is going to be the 3, so we would call this a third order differential equation. When you look here, you have y prime minus y is equal to e to the 2x. We know this highest derivative is a first derivative, so we call that the first order. And then finally, in the last one, the highest derivative is the second, so we have the second order. So that's what we talk about order of a differential equation. It's just based upon the highest derivative in the equation. When you look at the last two equations, notice they are expressed in the prime notation, which does not specify the independent variable. However, you'll be able to tell from the equation whether it's a dy dx or a dy dt. Again, when you look at the second to the last equation, you can tell that it's got to be a dy dx because you've got the x in the equation. And the last equation, you know it's going to have to be a dy dt. All right? So what we're going to first have to be able to do with these differential equations is do what's called a separation of variables. So basically, this is the procedure for solving differential equations of the first order. We're not going to get in to separation of variables for any other order of a differential equation besides the first order. So we're only going to be looking at the differential equations with the first derivative. So the way we're going to do our separation of variables, first of all, is we're going to separate the variables by writing the equation in differential form. So in other words, what you want to do is you're going to collect your y's, and that includes your dy on one side of the equation. You want to collect your independent variable. In this case, the x is on the other. So anything that has a y will go on one side. Anything that has your independent variable or x's will go on the other side. And then what you're going to do to solve your differential equation, you're going to integrate both sides of the equation. Because what now we're going to do, since we've got the differential equation, what we're trying to do is get back to figuring out what was the original equation, or what was your f of x equation actually going to be. So again, if your y's are on the left-hand side we're going to integrate with respect to y. The right-hand side we're going to integrate with respect to x, if you've got your x's on the left and your x's on the right. So right here we're going to integrate your h of y dy. That's going to be equal to the integral of g of x dx. So once you do your integration, again, we're looking at your h, once you integrate h of y dy, you're going to end up with, again, if g of x is my antiderivative, then my equation is going to be your g of x plus c. You'll then eventually want to be solving for y. Most of the directions will ask you to solve for y. So even though it could be free response questions, you've got to read the directions very carefully. If they say solve for y is equal to f of x, you actually have to go through the process and isolate y in the end. All right? In some cases, it may be possible to solve the equations explicitly for y. What that means is that you'll get that initial condition and actually solve for your constant of integration. All right? But obviously, if they're not giving you an initial condition, you can't solve for c, so you would just leave that plus constant there. All right, even though you're integrating both sides of the equation, you're not going to write a plus c on the left and a plus c on the right, because a constant is a constant is a constant. So you could subtract c on both sides. You only have to write that plus c one time. Okay? So any questions on that? So let's take a look at an example. So given the differential equation, find the general solution, y is equal to f of x. So notice in the first example, you have your dy dx is equal to 2 times the quantity of 1 plus y squared. So when they ask you to find the general solution, this means you actually have to solve for y in the end, because they're specifically telling you y equals. They don't give you an initial condition, so you know you're going to have that general plus c in your final answer. So notice you're given a first order differential equation. You have a dy over dx is equal to 2 times the quantity of 1 plus y squared. So the first step is you want to gather the x's on one side and the y's on the other. So the first step is you're going to multiply both sides of the equation by dx. Get the dx out of the denominator. So dy is going to be equal to 2 times 1 plus y squared x times your dx. So then you want to gather your terms that have a y in them. So notice this set of parentheses has your 1 plus y squared. So I'm going to divide both sides of this equation by 1 plus y squared. So my dy over 1 plus y squared is equal to 2x dx. So that's how you start with your separation of variables. Now notice you've got your y's, your dy's on one side, your x's and your dx's on the other. So any questions on the setup that I've done so far in the algebra? So now what we're going to do is we're going to integrate both sides of the equation. Well, what is the integral of dy over 1 plus y squared? That's your inverse tangent. So I have my inverse tangent of y is equal to, and again, when I integrate 2x, that's just going to be 2x squared over 2, which is just an x squared, plus c. So any questions so far on the integration that I did? Now the trick is, remember, what you have to do from here is you actually have to solve for y. How are you going to isolate y? You have to take the tangent of both sides of the equation. Just like you can add, subtract, multiply, divide, you have the inverse tangent of y, so you have to perform the inverse operation of the inverse tangent, which means you're going to take the tangent of both sides. So the tangent of your inverse tangent is just going to be y, is equal to the tangent. Remember, you have to take the tangent of the whole entire quantity of the right-hand side of the equation. So here is your final answer. So any questions on solving that particular differential equation? Now, if they use the y prime notation when it comes to your solving the general solution, you want to change this into your dy dx notation or whatever other independent variables in the equation. So we've got the y prime is equal to negative xy, so I'm going to rewrite this as a dy dx is equal to negative x times y. So again, get rid of the fraction, so multiply both sides of the equation by dx. So dy is equal to negative xy times your dx. Again, you want to move anything that has a y to the other side of the equation, so I'm going to divide both sides by y. So dy over y is equal to negative x dx. And again, I'm going to integrate now both sides of my equation. So what is the integral of dy over y going to be? Natural log of y is equal to my negative x squared over 2 plus c. I heard of Miss Bertie, didn't I? I thought, am I hearing things? How do I solve this one for y? Raise it to the base of what? E. Remember, we call this exponentiating the equation. So I'm going to take my e and raise that whole entire equation to become the exponent. So we call that exponentiating the equation. It's because what happens when you have e raised to the natural log of y? That's just going to give me a what? Y equals e to the negative x squared over 2 plus c. Remember that plus c is also in that power. Now, you're very rarely ever going to see an answer written like this, nor are you going to leave an answer like this for me when they ask you to solve for y. Go back to your properties of exponents. You learned back in Algebra 1 properties of exponents. When do you add powers together? You add powers together when you do what with their bases? Multiply. So another way to look at this right-hand side of this equation is have e raised to the negative x squared over 2 times e to the c. Do you agree that's equivalent? E to the negative x squared over 2 times e to the raised to the c power. So now, what is e raised to the c? That's just a what? It's just a constant. So then the more simplified way to write this is y is equal to c times e raised to the negative x squared over 2. And when we get to our exponential growth and decay in the next section, get used to seeing it this way. So anytime you see that addition sign in an exponent, you're undoing those properties of multiplication using that exponent rule. All right, so any questions where I got c times e raised to the negative x squared over 2? Okay. So like I said, there's going to be some cases where you're going to actually have to solve for c. So again, you've actually done some of these earlier, but again, the initial value problem will be coming up again. It's when you're given the value of x and y at a particular point. So this is where you're actually going to solve for c. So find the solution, x is equal to g of y. So now be careful, read these directions. In your final answer, are you going to be solving for x or are you going to be solving for y? X. So you're going to be isolating x once we get done the integration. So here, find the solution of this differential equation with the initial condition g of 0 is equal to 0. So notice they have to give you that x and the y value. So that's the value that we're going to use to help us solve for c. So you still have to start with your separation of variables. So you've got to collect your x's on one side and dx, your y and dy on the other. So in this case, before I multiply both sides by dx, I'm going to first move that minus 3x squared to the right-hand side. So I have 4y minus cosine y dy dx is equal to 3x squared. Now I'm ready to go ahead and multiply both sides by dx. So I have 4y minus cosine y dy is equal to 3x squared times dx. Now I'm going to go ahead and I'm going to integrate both sides of this particular equation. So when I integrate 4y, that's going to give me a 4y squared over 2, or just a 2y squared. What's your integral of cosine y? Your integral of cosine y is just going to be a sine y. Equals, when I integrate 3x squared, that's going to be a 3x to the third over 3, or just an x to the third plus c. Now remember, you're going to be plugging in values for x and y. So you don't need to algebraically solve for c and then plug the numbers in. It's easier to solve once you plug in those constants. So remember, they're giving you this initial condition. So to solve for c, you look at this initial condition that's given. The g of 0 is equal to 0. So my x value is 0, my y value is 0. So when I plug them in, I have 2 times 0 squared minus sine of 0 is equal to 0 to the third plus c. What's sine of 0? 0. So then what's my c value going to be? C is going to be equal to 0. So then I have 2y squared minus sine y is equal to x to the third plus 0. Obviously, you don't have to write the 0, but I'm just showing you that's what you would do if it wasn't a 0. You'd plug it in. Now, what are you solving for? Go back to the directions. Are they asking you to solve for x, or are they asking you to solve for y? X. So what are you going to have to do to both sides of this equation? You're going to have to take the what? Cube root. So x is going to be equal to the cube root of 2y squared minus sine y. So any questions on that one? So here's another one where they're giving you, again, in the y prime notation, but again, they're giving you this initial condition, f of 0 is equal to 3. So anytime they give you an initial condition, after you get done using your separation of variables, you are actually going to solve for c. Again, my first step is going to be to set up this dy dx is equal to 6x minus x to the third over 2y. What do you think your first step is going to be in this one to start separating the y's and the x's from one another? What do you think you're going to do first? Multiply by 2y, and then you're going to multiply by what? Dx, exactly. So 2y dy is equal to, make sure you have parentheses around that, 6x minus x to the third dx. Now I'm going to integrate. So when I integrate 2y, that's going to give me 2y squared over 2, or just a y squared, equals. Again, when I integrate 6x, that's going to give me a 6x squared over 2, or just a 3x squared, minus x to the fourth over 4 plus c. Any questions on what I've done here? So now to solve for c, I have to use this initial condition, f of 0 is equal to 3. So I'm going to plug 0 into this equation for x and 3 in for y. So 3 squared is equal to 3 times 0 squared minus 0 to the fourth over 4 plus c. So what's c going to be equal to? C will be equal to, c is going to be equal to 9. So now I take this 9 and I plug it into my general solution. So I have y squared is equal to 3x squared minus x to the fourth over 4 plus 9. Now how do you solve for y? Square root. Now anytime you take the square root of both sides of the equation, what do you have to remember to put in front of the radical? Plus or minus. Now, this is where I need to caution you. Your answer is not going to have plus or minus. You have to decide which one it's going to be. So you have to decide whether it's the plus or minus. Your answer will not have both. So you have to decide which one it's going to be. The way you decide which one it's going to be is going to go back to the initial condition that's given. So they're giving you the initial condition of f of 0 is equal to 3. Remember, 3 is your y value. This y value of 3, is that positive or is that negative? Positive. So since your y value is positive, remember, this equation is set up in the form of y equals. So all your y values have to be positive. So in this case, we're going to choose the positive because the initial condition has a y value that's positive. So y is equal to the positive square root of 3x squared minus x to the fourth over 4 plus 9. So any questions on how you can decide whether or not you're going to choose the positive or whether you're going to be choosing the negative? So we're moving right along here. So find your solution, y is equal to f of x, given this differential equation. So we have e to the x squared y times y prime plus x equals 0. And again, they're giving you the initial condition, f of 0 is equal to negative 2. First of all, I'm going to rewrite that y prime as your dy dx plus x is equal to 0. What do you think your first step's going to be to start separating the x's and dx's and y's and dy's? I think your first step will be. Well, what are we going to do? What do you think we're going to do with this plus x? Subtract that x. Then what? What do you think you could do next? Sometimes there's more than one correct answer here that you could do. What do you think you're going to have to do next? I have my y and dy dx over here, so what do you think my next step could be? Divide by e to the x squared. Then finally, what do you think the last step's going to be? Multiply by dx. So now what do you have to do? You're going to have to do what? Integrate both sides. Well, I know the integrating y is just going to give me a y squared over 2. The question is, how do I integrate that negative x over x squared? It's going to be a u sub. It's going to be a u sub. So u is going to be equal to x squared. My du is going to be equal to that 2x dx. So again, I can pull the negative out of my integral. And what else am I going to have to take out of this integral? I'm going to have to take out a what? A half. So again, this is going to be negative 1/2 times your integral of 1 over u du. E to the u. Make sure you pay attention. How are you going to integrate 1 over e to the u? Well, you can rewrite it as a what? E to the what? Negative u. Probably would have been easier now that I'm doing it. You probably could have rewritten this as an e to the negative x squared to begin with, because what am I going to actually now have to take out of this integral again? I'm going to have to take out a what? Because technically I have to do another u sub, don't I? So really what's going to happen with this negative sign on the outside? It's going to do what? It's going to cancel out. So I have a 1/2 times the integral of e to the, so if I let v be equal to negative u, my dv would be a negative du. So e to the v dv. Probably would have been easier from the beginning had I just written this as an e to the negative x squared. That way it would have avoided that double substitution. So now remember, I have y squared is equal to 1/2 times, remember, e to the v is e to the negative u. And that u, remember, I let be equal to x squared, so that's e to the negative x squared. So it's going to be 1/2 e to the negative x squared plus c. Yeah, it definitely would have been easier had I done this at the beginning back here, had I just integrated that e to the negative x squared times negative x dx. You could have done it that way, and that way you could avoid that double substitution there. All right? Sometimes hindsight's a wonderful thing. All right, so any questions, guys, on how I did that particular integration? So now what do you have to do? You have to solve for what? We're going to solve for c. So again, my initial condition is my f of 0 is equal to negative 2. So plug negative 2 in for y and plug in 0 for x. So negative 2 squared is 4. 4 divided by 2 is 2. Equals 1/2 times. When I plug 0 in for x, e raised to the 0 is just going to be what? 1. So I have 2 is equal to 1/2 plus c. So then what's c going to be equal to? C will be equal to, when I subtract a half, that's going to give me what? 3/2. So any questions where I got 3/2 from for my c value? So now I can plug c back into my general solution. Erase that. So y squared over 2 is equal to 1/2 e to the negative x squared plus 3/2. Now I have to start solving for y. What's going to be your first step to start solving this equation for y? Multiply everything by that denominator of 2. So then y squared is equal to e to the negative x squared plus 3. Then what? I'm going to take the what? Square root. And what do you have to remember to put in front of your radical when you do your square root? Plus or minus. So y is equal to plus or minus the square root of e to the negative x squared plus 3. Do I leave both the plus and the minus in the front? No. So the question is, which one is it going to be? Am I going to choose the positive or am I going to choose the negative? Well, look at your initial condition. Your initial condition was f of 0 is equal to negative 2. So am I going to choose the positive or negative in front of that square root? The negative. So y is equal to the negative square root of e to the negative x squared plus 3. So any questions on that particular example? So here's just a twist on the way that they may ask a particular problem involving the initial condition and using separation of variables. So they want you to find a curve. So that just simply means they want you to find an equation that passes through a point 0, negative 3, and whose tangent line at a point has a slope of 2x over y. Well, when they tell you slope, what are they actually giving you? They're giving you what? The derivative. So I know that my dy dx is equal to 2x over y. So I know my slope. What do you think that point 0, negative 3 is? That 0, negative 3 we're going to treat as our what? Initial condition, the initial value. So you guys go ahead and try this one on your own. Go ahead and do your separation of variables and then see if you can solve for C. So you should end up with y squared over 2 is equal to x squared plus c after you've done your integration. And then you end up with a constant of 9/2. And then when you go to do your square root, you have to choose the negative in front of the radical because your initial condition had a negative y value. So any questions on using your separation of variables in order to help you solve these general solutions and the initial condition in solving for C? Okay. All right, so we were able to do the lesson in the shortened period today. Look at that. So I'm going to have time to check your homework here. Gosh darn it. I thought I was going to...